Okay, let's consider this problem. There are two blocks. Block A and block B has a weight of 6 pounds, okay, and 12 pounds. Okay. This is US customary unit. Okay, you have to be careful when we use the unit that is maybe not the same that's we familiar with. That is that's R is maybe for SI unit. Okay, for this case, for US customary unit, normally in US customary unit use weight as the base unit. So then this is already the weight, and actually it's still unit is the force already. Actually, in some texts maybe like this. This is the power force. Okay, and so when we would like to find mass, we have to it's actually for WA. Now we know WA is equal to 6 pounds. Okay, so then when we would like to find mass of A, okay, we have to divide it by G. Okay, that is in US customary unit, G is 32.2 foot per sec square. Okay, and then we will have the mass. Okay, that is the unit is in slab. Okay, unit of mass is slab. Okay, so for this case, after striking, block A is like 2 inch to the right. Okay, 2 inch, not 2 foot, 2 inch. So we have to convert it to foot also. And block B is like 3 inch to the right. Okay, and if the coefficient of kinetic friction between the block and the surface is 0.2, determine the coefficient of restitution between the block. And we the problem gives us that the block B is originally at length. This means that the velocity of block B at before impact is equal to 0. Okay, so we starting with state of our problem. Now that's for this case, we know that the weight of block A equal to 6 pounds, weight of block B is equal to 12 pounds. Okay, and then if we would like to find mass, we have to divide it by 32.2 foot per sec square. Okay, and for this case, we know that at the first step, and it's just after impact. That's for the case that block A is moving to hit the block B. We don't know the velocity of block A now. Okay, and block B we know because it is at least for at the first step, and after it leave, okay, we assume that it leave, and it's because we assume that it's not go together now, and we have VA2 and VB2. Okay, and after it leave, after impact, when it's moving, and then it stop according to the friction, it stop. And for the stop position, we know that block A is like 2 inch, okay, and block B is like 3 inch. Okay, which is maybe just like this. We can measure, which is just 2 inch. Okay, and block B is maybe 3 inch. It's maybe like this. Okay, so for this case, we would like to determine back for coefficients of restitution between block. Okay, so then we have to determine back. We consider the final state first. That is the state number 3. And we because it's under friction, we have to apply the principle of work and energy principle. That is we know that kinetic energy at the final position is equal to the kinetic energy at the second position plus the work done from 2 to 3. Okay, at the final position, the block is stopped. So then it's the kinetic energy becomes zero, and initial positions, that's after impact, we have the kinetic energy of this. That's VA as after impact is the unknown, we don't know now. Okay, and the friction force, which is opposite to the directions of motion. So then it is the resistance force, and it's produced the resistance work. The work done is negative now, and we substitute the mg is the weight already. Okay, and the coefficient of kinetic friction is equal to 0.2. Okay, substitute this into equation. Be careful for this problem because we have a lot of unit. As we have to convert it for consistency unit. Okay, and we change inch to be foot by divided by 12. Okay, and after we solve this equation, we obtain velocity of block A become 1.46 foot per second. In the same manner for block B, we do it same, okay, but with the different weight, okay, and different distance, okay, and after that we obtain the velocity of block B here, that is 1.79 foot per second, okay, and after that we consider back. Now we know this position already, okay, we know the velocity of A and B after impact. We have to come back to determine the velocity of block A before impact. Okay, but velocity of block B we already know because it's at least it's become zero. So then when we consider the conservation of momentum, okay, we already know VA, VB as the after impact and the plate after impact. And we know VB1, that is before impact, it is at least, so then it becomes zero. Okay, we have just only one unknown. So after this equation, okay, we obtain velocity of block A now. Okay, after we have the velocity of block A, okay, we can use the velocity of block A and block B for state number 1 and state number 2, substitute into coefficients of restitution equation. So then we obtain the value of coefficients of restitution for this problem is equal to 0.065. Okay, that's complete this problem.